The independent variable, jargon is what gets you in math, you guys. It's the jargon. The independent variable is just the variable that represents the inputs, okay? So we didn't use a variable above because we had a finite set of ordered pairs as our function, but very soon we're going to be using a variable. So the domain, the independent variable, it's really the letter or the that we think of as a variable that represents the first coordinate. It's a generic first coordinate. If you like to think in terms of x and y, it represents the x coordinate. And if we really are using x would be the independent variable. It would represent any input in that case. So the independent variable, it's a letter, it's a variable that represents an input value to a function. Okay? And then we have the idea of a dependent variable. It's a letter or a variable that represents an output to a function. So if you're thinking in terms of your ordered pairs x and y, remember we do that when we plot points on the xy plane, then x is your input variable. It's also called the independent variable. Independent variable. And y is the dependent variable. Oftentimes. But if you're not using x to represent the input and y to represent the output, maybe you'll use m and n. Then what's your independent variable then? M. It's just the first guy. What's your dependent variable? N. Never changes. It's the same every time. Okay, to put these two definitions into some sort of context, let's do this example. Planet Express charges different amounts of money to deliver a package according to its weight. Suppose you write down a function that relates the cost of mailing a package and its weight. Which quantity is the independent variable? So the idea here is it costs more money to deliver like a 1 pound package versus a letter that weighs a few ounces. So the cost, you can think of it this way. The cost, which we'll call C, depends on the weight of the letter, which we'll call W. So, you know, the weight might be in ounces or pounds, whatever it's in. And the cost would usually be in dollars. Or if it's a letter, it'd be in cents, but you can do the conversion. So the weight, here's my argument. The weight would have to be the independent variable. Because think about it. The cost of mailing a package depends on how much it weighs. It depends on weight. So if you were going to make a formula, oftentimes you can think of a function as a formula. If you were going to make a formula or a function that relates the cost of mailing a package versus its weight, W would be the independent variable. The weight would be the independent variable. Since cost depends on weight. If you were going to make an ordered pair representation using the two letters C and W, W would come first and C would come second. The independent variable represents the input to the function.